Integration by guessing. That's what we're looking at. You're going to guess, and then you're going to see if your answer's right. Usually the basic technique for integration is going to be guessing. You guess, and then you try it out. So if we're integrating this, you're going to guess something, then you're going to differentiate it and see if you got it right. Hopefully, the more you do these, the more you'll see a pattern so that you guess more effectively rather than having to guess like 20 times. If you're really bad at these, you're going to be guessing a lot. You need to pay attention, see if there is any sort of pattern. Not that they can be applied to every problem, but just see if there is something that you can notice on the problems. So we've got this, integrate 6 times x plus 1 to the 5th dx. So we just want to pick something. What do you think that it might be? Okay. If you take the derivative of that, what would you do? Move the 6, and then x plus 1 to the 5th, and then what else do you have to do? What is the derivative of this? 6 times 1 is, so we just have 6x plus 1 to the 5th. Is that what we started with? So what is our actual answer? Is it just this? Yeah, plus c. Does that make sense? Any questions there? Okay. Looking at another one. Integrate 7 sine t to the 6th cosine t dt. What would we want to do on this one? You think cosine? Okay, we can try that. So you could also write this like that if it helps you. Okay, that would be 7 cosine to the 6th t. And then what do you have to do? Take the derivative of cosine? What is the derivative of cosine? Does that look like this? Okay. Let's try sine to the 7th t. If you need to, you can write it like this. It really doesn't matter. Okay, so 7 times what? Does that make sense? And then what? Times cosine. Is that what we have up here? So what would be our answer? Does that make sense? Do you see how that works? If you're dealing with trig, one has a power, one doesn't. Usually it's going to be the one that has the power that you're going to use. Not always. Mm-hmm. Mm-hmm. Yeah, you can put the power in between the argument and the sign, or you can put it like outside of it. Any questions on that one? Okay. Looking at another one. You think so? That's what Christian and Jeremiah say. Any other guesses? Huh? You think it's it? Okay, why? If you take the derivative, what do you get? And then times 1, right? Which is what we have here. X plus 7 to the 1/2, it's the same thing as the square root of x plus 7. Doesn't matter how you write it. Does that make sense? Y'all see how these work? Not too difficult, are they? You got to be efficient in your guessing. That's all. Okay, see if you can do this one by yourself. If you need to rewrite it, you can. I'll let you guess, and then I'll show you how you can rewrite it. You may need to rewrite it, you may not. Does everyone have a guess? Anyone still working? Yes? Okay. If that helps you to rewrite it like that, you can. It really doesn't matter. Okay? No, you can't move it. Well, I mean, you could, but it'd be 3 times 2 to the -1, which is really a weird way to write it. Anybody have a guess? Okay, x cubed plus 4. You think that? The parentheses found it. No. Okay, Matthew's saying that's the answer. Anybody else have a different answer? Okay, if this was it, that's x to the 3rd plus 4, all of that to the 1/2, right? Okay. If you took the derivative, you would make it to the what? To the -1/2. And then what number would come out here? Does that make sense? But then what would you have to do? What is this derivative? So if you clean it up, 3x squared times 1/2 is what? Is that what we started with? Does that make sense? Y'all see how that works? So that is actually your answer. Any questions on how these work? Okay. Looking at this one, see if you can do it by yourself. Anybody have a guess? No one? Yep. What? If you take the differential of this, what would you have to do? Product rule? Product rule is going to result in 2 terms, right? How many terms do we have up here? 1. So is this going to be right? No. Anybody else have an idea? Make it e to the what? Okay. If you take the derivative of that, what would you do? Anytime you take the derivative of e, you just write it, right? And then you take the derivative of its exponent. What is the derivative of this? Is that right? No. That's not what we started with. If you integrate e to the x, what is that? Okay, so we've got an e to the x in there. What is our e to the x, though? E to the 4x squared. Does that make sense? Anytime you integrate e to the x, like you're always going to have that same thing in both. Is it? You think so? Okay, so if you take the derivative, it'd be e to the 4x squared, and then times what? 8x. Does that make sense? Do you see how that works? Okay, let's go back over them real quick. For this one, what part did we look at for our actual final answer? Did we look at the 6 really? What did we look at? The part that's in the parentheses? Whoop. This part? Does that make sense? For this one, what did we look at? Why the sine and not the cosine? We looked at the one that had the exponent. Does that make sense? Okay. If you look at this one, what did we look at? The square root part. Kind of like parentheses to the 1/2. Does that make sense? For this one, what did we look at? The square root part. The parentheses part if you make it to the 1/2. And then for this one, what did we look at? The e to the x. Anytime you have an e to the x, start with that, like this. Start with just that and see if that's the actual answer. Does that make sense? Any questions on these? Yeah. Yes. That's just how they refer to it. I don't know. Any questions on these? Okay.